Reversibility. In this course of thermodynamics, we're going to be interested in processes that we're going to assume are reversible, or pretty much close to reversible. We have illustrated here a piston with a volume of gas inside and a heat reservoir through which heat can flow either to or from. We're going to define a process that is reversible by an infinitesimal modification to the surroundings, so the system is able to adjust each time. In this case, what we're going to do is depress the piston by dropping sand grains slowly onto the piston, so that the volume will change very slowly, and so the temperature will rise very slowly. And so each time we add a grain of sand, the gas reaches a new equilibrium pressure and temperature. And each time we do that, an infinitesimally small amount of heat will flow to the heat reservoir at the bottom. Again, we should note that no process is perfectly reversible, but some processes are approximately reversible, and they're the kind of processes that we're going to try and reproduce that occur in the atmosphere on diagrams in order to assess what the atmosphere is doing. If we depress the piston quickly and wait for equilibrium to be established with the heat reservoir, what we'll find is that you'll have an initial P and T, a pressure and temperature for the gas in the piston, and you'll have a final pressure and temperature, but the pathway between those two states is not well defined. In other words, the gas will move through a turbulent state each time, and the process will be difficult to plot, or if not impossible to plot on a graph. We define that as an irreversible process.